Worlds not meant for humans. Why Earth may be incredibly rare. Have you ever wondered, what if Earth isn't actually normal? Not because it is the largest planet, not because it shines the brightest, and not because it sits at the center of the universe, but because it is almost impossibly balanced. Every morning the sun rises. Every evening darkness returns. Rain falls from the clouds, and what touches the ground is water. A year lasts long enough for trees to shed their leaves, for people to grow, for memories to form, and for life to keep moving forward. We have lived with these things for so long that we almost forget how extraordinary they are. But if you look out there, into star systems hundreds or even thousands of light years away from Earth, you begin to realize something strange. The things we call normal may not be common at all, because the universe does not only create blue planets, it also creates worlds so extreme that simply hearing about them is enough to send a chill down your spine. There are planets where a year does not last 365 days. Not 100 days, not even 10 days, but only a few hours. While you sleep through a single night on Earth, somewhere out there, a planet may have already completed an entire orbit around its star. 1 year ends, a new year begins, and then it ends again. At first, that may sound fascinating, but behind that strange number lies a brutal reality. For a year to be that short, the planet must be orbiting extremely close to its star. So close that each orbit no longer feels like a peaceful journey through space. It becomes more like a desperate race around the mouth of a gigantic furnace. If the planet slows down, even slightly, it could be pulled into its star. If the tidal forces become too strong, it could be torn apart. If it remains too close for too long, its atmosphere may be stripped away, its material blown into space, until the planet slowly becomes a glowing, burned-out remnant. Here on Earth, a new year is often a symbol of hope, but on worlds like those, every new year may simply mean one more orbit closer to erosion, collapse, or destruction. And that is only the first file. In other corners of the galaxy, even the sky itself becomes unfamiliar. Imagine standing on a planet where, when you look up, you do not see one sun, you see two. One star is rising over the horizon, another still hangs in the distant sky. The ground beneath your feet does not cast one shadow, but two, stretching in different directions. Day is no longer simply bright. Night is no longer guaranteed to be dark. Sometimes one sun has already set, but the other is still shining. Sometimes both appear at once, pushing temperature, light, and climate into rhythms Earth has never known. The sight might be breathtaking, but beauty does not always mean safety. Life does not only need light, it needs stable light. It needs temperatures within a narrow range. It needs a steady enough rhythm of day and night for bodies, climates, and ecosystems to adapt. More suns do not necessarily create a better world. Sometimes more light only creates more chaos. And then, at the opposite extreme, there are planets with no sun at all. No sunrise, no sunset, no nearby source of light to warm them. These are rogue planets, worlds that may have been thrown out of their home star systems, drifting alone through the darkness between the stars. If you stood on a planet like that, the sky above you might be almost completely black. No sun to serve as a center, no familiar orbit to call home, no new day in the way humans understand it. Only darkness. cold and silence. But here is the mystery. Darkness does not always mean the end. If a rogue planet has a thick outer layer of ice, and if its interior still holds heat from its core, there could be a hidden ocean beneath that frozen shell. And if there is water, heat, and minerals, then a question begins to appear. Could some form of life exist without ever knowing the sun? Could there be a world quietly alive in the dark? A world that has never seen a sunrise, yet is not entirely dead. We do not know, and that very phrase, "we do not know," is part of what makes the universe so compelling. Human beings often want certainty. We want to close the case quickly. We want to know clearly what is real and what is not. But the universe is not in a hurry. It leaves behind tiny clues. A star dims for a moment. A signal repeats. A light curve behaves strangely. And then humanity is forced to observe, infer, debate, and wait for more data. Some mysteries do not begin with an explosion. They begin with a tiny change in light, like a whisper, moving through the void. And from those whispers, humans discover why. Even stranger than before, there are planets so hot that iron can evaporate. On the day side of such a planet, metal is heated into vapor within the atmosphere. Massive winds carry that iron vapor toward cooler regions. There, it condenses and falls, not as water, but as molten iron rain. Picture a sky, glowing red, metallic clouds, twisting in violent currents, drops of molten iron falling through the atmosphere, like burning fragments of fire. On Earth, rain can make people feel calm, but on that world, rain is a sign that the planet cannot support life as we know it. The same word, rain, can mean something entirely different, depending on the world it belongs to. And that makes us look at familiar things with different eyes. A normal rainstorm, outside your window, an atmosphere you can breathe, a temperature that does not make metal boil away. None of these things are ordinary. They are the result of an incredibly delicate balance. But the universe does not stop there. There are planets so hot that they exceed the temperature of some small stars. They are not stars because they do not generate their own energy through nuclear fusion in their cores, but because they orbit extremely close to a blazing hot star. They are intensely heated from the outside. Their atmospheres swell, molecules break apart, material slowly escapes into space. The planet still orbits, it still exists, it still has a name in scientific data, but in reality, it is slowly losing itself, not in an explosion, but through gradual erosion, layer by layer, orbit by orbit, piece by piece, disappearing into the dark. Perhaps this image is closer to human life than we first realize. Being close to the light is not always a good thing. Some sources of light nourish us, but others burn us. If we get too close, fame, ambition, pressure, recognition, all of these can become fuel. But if we allow them to become the only star pulling us forward, we too can be worn down from within. A giant planet can still be fragile if it is in the wrong place. A strong person can still become exhausted if they live in an orbit that is too hot. And in another file, the universe overturns our intuition. Even further, there may be planets that are physically larger than the stars they orbit. It sounds absurd, but if the host star is a white dwarf, a small but incredibly dense, stellar remnant. Then a giant gas planet orbiting it could be larger in diameter. From a distance, the center looks small. The object orbiting it looks huge. But gravity is not fooled by appearances. A white dwarf may be small, but it can still contain enormous mass. It remains the center. It still holds the planet in orbit. And that reminds us of something simple. The largest thing is not always the most important, and the smallest thing is not always weak. In the universe, as in life, some quiet things carry tremendous weight. Finally, there are planets, or perhaps other kinds of objects that may possess enormous ring systems. So beautiful, they almost seem unreal. If Saturn has already amazed us, imagine a ring system far larger, wide enough that when it passes in front of its star, it causes the starlight to dim in strange and complicated ways. But this is a case that remains open. It may be a planet with a gigantic ring system. It may be something else entirely. The data may be telling a story we do not fully understand yet. And that is exactly what makes it so fascinating. Not knowing is not failure. Sometimes, knowing that we do not yet know is the beginning of clarity. In today's video, we will not simply travel through some of the strangest planets in the universe. We will open each file to uncover a deeper truth. The universe does not lack planets, but a planet balanced enough for life to emerge may be far rarer than we think. Earth is not perfect, but it is gentle enough, bright enough for life, dark enough for rest, warm enough for water to flow, stable enough for human beings to look up at the sky and ask questions, and sometimes only after looking far away at worlds not meant for humans do we realize how precious the ground beneath our feet truly is. The planet with an absurdly short year. Let's begin with something that feels very familiar: a year. For us, a year is 365 days. It is the time Earth takes to complete one orbit around the Sun. A year is long enough for a child to grow a little older, long enough for trees to move through seasons of changing leaves, long enough for people to make plans, fail, learn, and begin again. We are so used to that rhythm that we almost assume a year has to be that long. But in the universe, a year does not have one fixed meaning. It is not an emotional unit. It is not a span of time designed for human life. It is simply the amount of time a planet needs to complete one orbit around its star. And if that planet is extremely close to its parent star, a year can become so short that it makes all of our familiar ideas about time feel strange. There are exoplanets where a year lasts only a few days. There are worlds where a year passes faster than a weekend on Earth. And in the most extreme cases, a planet may complete an entire orbit in just a few hours. In the original script you shared, the section on the shortest year explains that some exoplanets have extremely short orbital periods because they orbit very close to their stars, and that this also makes them easier to detect since their repeated dips in starlight happen more often. Think about that for a moment. You sit down to watch a 2-hour movie. By the time the movie ends, somewhere far away, a planet may have already lived through nearly half of its year. You sleep through one night. Out there, 1, 2, or even several years may have passed. If humans lived on a world like that and measured age by the local calendar, age itself would start to lose meaning. A newborn, only a few Earth days old, might have already celebrated dozens of New Years. But don't let that strangeness fool you. A short year is not a cheerful thing. It is not just a fast-running clock that makes the planet seem interesting. It is a sign of an extreme environment. Because for a planet to orbit its star in only a few hours or days, it has to be very close to that star. So close that it lives beside an enormous source of fire. So close that light is no longer only a source of life. It can become a sentence. Here on Earth, the sun rises gently in the morning. It warms the oceans. It powers photosynthesis. It helps sustain the climate. But for a planet orbiting too close to its star, that star no longer feels like a life giver. It becomes a furnace. Every orbit sends the planet through an intense field of heat. If the planet is rocky, its surface may be heated until it glows red. Stone may melt into oceans of magma. Its atmosphere, if it still has one, may be heated, inflated, and slowly stripped away into space. At such a close distance, the star's gravity also becomes terrifying. It does not merely hold the planet in orbit. It stretches the planet. It creates powerful tidal forces. It can heat the planet from within. And if the planet moves too close to its limit, it could be torn apart into fragments of material circling the star like a ring of ash. In other words, an extremely short year may be the sign of a planet living at the edge of existence, the boundary between a stable orbit and a final plunge, the boundary between a planet and debris, the boundary between a named world and an object slowly being swallowed by its star. That is what makes this file so compelling, because it does not only ask, how short can a year be? It asks something much darker. How close can a planet come to death and still continue to exist? Science is searching for answers by studying light. When a planet passes in front of its parent star, from our point of view, the star's light dims slightly, very slightly, almost like the universe blinking. But if that dimming repeats at regular intervals, scientists can infer that a planet is orbiting the star. The shorter a planet's orbit, the more often it passes in front of its star. That makes it easier to detect. If a planet takes several years to complete one orbit, we have to wait a long time to confirm the signal. But if it takes only a few days or even a few hours, the pattern appears much faster. This teaches us something important about how we read the universe. What we see most often is not always what is most common. Sometimes it is simply what is easiest to observe. Ultra-short-year planets do not necessarily represent the entire galaxy. They are just the cases that light reveals to us more easily. The same is true in life. The loudest thing is not always the most important. The thing that appears most often in front of us is not always the whole truth. Some things are quieter, farther away, slower, harder to see, but they still exist. The universe teaches us humility in a very clear way. Before we rush to a conclusion, we should remember that the way we see is always limited by our position, our tools, and the amount of time we have been watching. No. The planet with an absurdly short year. Let's begin with something that feels very familiar. A year. For us, a year is 365 days. It is the time Earth takes to complete one orbit around the sun. A year is long enough for a child to grow a little older, long enough for trees to move through seasons of changing leaves, long enough for people to make plans, fail, learn, and begin again. We are so used to that rhythm that we almost assume a year has to be that long. But in the universe, a year does not have one fixed meaning. It is not an emotional unit. It is not a span of time designed for human life. It is simply the amount of time a planet needs to complete one orbit around its star. And if that planet is extremely close to its parent star, a year can become so short that it makes all of our familiar ideas about time feel strange. There are exoplanets where a year lasts only a few days. There are worlds where a year passes faster than a weekend on Earth. And in the most extreme cases, a planet may complete an entire orbit in just a few hours. In the original script you shared, the section on the shortest year explains that some exoplanets have extremely short orbital periods because they orbit very close to their stars, and that this also makes them easier to detect since their repeated dips in starlight happen more often. Think about that for a moment. You sit down to watch a 2-hour movie. By the time the movie ends, somewhere far away, a planet may have already lived through nearly half of its year. You sleep through one night. Out there, 1, 2, or even several years may have passed. If humans lived on a world like that and measured age by the local calendar, age itself would start to lose meaning. A newborn, only a few Earth days old, might have already celebrated dozens of new years. But don't let that strangeness fool you. A short year is not a cheerful thing. It is not just a fast-running clock that makes the planet seem interesting. It is a sign of an extreme environment, because for a planet to orbit its star in only a few hours or days, it has to be very close to that star, so close that it lives beside an enormous source of fire, so close that light is no longer only a source of life. It can become a sentence. Here on Earth, the sun rises gently in the morning. It warms the oceans. It powers photosynthesis. It helps sustain the climate. But for a planet orbiting too close to its star, that star no longer feels like a life giver. It becomes a furnace. Every orbit sends the planet through an intense field of heat. If the planet is rocky, its surface may be heated until it glows red. Stone may melt into oceans of magma. Its atmosphere, if it still has one, may be heated, inflated, and slowly stripped away into space. At such a close distance, the star's gravity also becomes terrifying. It does not merely hold the planet in orbit. It stretches the planet. It creates powerful tidal forces. It can heat the planet from within. And if the planet moves too close to its limit, it could be torn apart into fragments of material, circling the star like a ring of ash. In other words, an extremely short year may be the sign of a planet living at the edge of existence, the boundary between a stable orbit and a final plunge, the boundary between a planet and debris, the boundary between a named world and an object, slowly being swallowed by its star. That is what makes this file so compelling, because it does not only ask, how short can a year be? It asks something much darker. How close can a planet come to death and still continue to exist? Science is searching for answers by studying light. When a planet passes in front of its parent star, from our point of view, the star's light dims slightly, very slightly, almost like the universe blinking. But if that dimming repeats, at regular intervals, scientists can infer that a planet is orbiting the star. The shorter a planet's orbit, the more often it passes in front of its star. That makes it easier to detect. If a planet takes several years to complete one orbit, we have to wait a long time to confirm the signal. But if it takes only a few days or even a few hours, the pattern appears much faster. This teaches us something important about how we read the universe. What we see most often is not always what is most common. Sometimes it is simply what is easiest to observe. Ultra-short year planets do not necessarily represent the entire galaxy. They are just the cases that light reveals to us more easily. The same is true in life. The loudest thing is not always the most important. Planets with multiple suns. If the first file showed us that time on other planets can be nothing like time on Earth, the next one makes something even more familiar feel strange. The sky. We were born under a sky with one sun. Every morning, it rises. Every evening, it sets. That single source of light creates the rhythm of day and night, the seasons, the climate, our sleep, our alertness, and even the way we feel, the passage of time. A day begins when the world becomes bright. A day ends when darkness returns. That order is so familiar that we almost never question it. But out there, in distant star systems, there are planets where the sky is not that simple. There are worlds with more than one sun, two, maybe even more. Imagine standing on an alien planet. Morning does not begin with a single glow on the horizon. Instead, a yellow-white sun rises in the east, while a smaller, deeper red sun still hangs in another part of the sky. The ground beneath you does not cast one shadow. It casts two, one dark, one faint. They stretch in different directions, as if your own body is being pulled into two different rhythms of light at once. Then evening comes. One sun sinks below the horizon, but the sky does not fully darken because the second sun is still there. Light continues to wash over the surface. Night does not arrive on schedule. Darkness is no longer guaranteed, and any living thing on that planet, if life exists there at all, would have to adapt to a completely different kind of time. This is not just a scene from science fiction. In the real universe, binary star systems and multi-star systems exist. Two stars can orbit a shared center of mass. Three stars can form a layered structure. Two stars orbit each other as a pair, while that pair interacts with a third star farther away. Even more complex systems can exist. Though the more stars involved, the harder it becomes for the system to remain stable over long periods of time. And within those systems, planets can still form. Some planets orbit one star within the system. Some orbit both stars together. Some may orbit far out, circling the entire star system like an enormous outer ring. This raises a fascinating question. What would life be like on a planet with multiple suns? First, there is the question of light. On Earth, sunlight is the foundation of almost all surface life. Plants use light to produce energy. Climate depends on heat from the sun. The human body depends on cycles of light and darkness to regulate sleep, hormones, mood, and alertness. We do not simply live under the sun. We live according to its rhythm. But on a planet with two suns, that rhythm could be divided, stretched, or disrupted. Sometimes, both suns may appear at once, making daytime brighter than usual. Sometimes, one sun may follow the other, extending the length of the day. Sometimes, one star may pass in front of the other, creating strange eclipses. Sometimes, the sky may shift from bright light to dim light before it ever becomes truly dark. If life existed on such a planet, it could not simply run on a biological clock like ours. It would have to respond to multiple sources of light, multiple cycles, multiple overlapping changes. Plants, if they existed, might not sleep according to night, the way we imagine. Animals might not be clearly divided into daytime and nighttime species. Life there might evolve to sense the position of each sun with incredible precision, knowing when heat will rise, knowing when radiation will become stronger, knowing when to hide and when to become active. In other words, a sky with multiple suns is not only beautiful, it forces life to become intelligent in a different way. But light is only the most visible part of the story. The more dangerous part lies in temperature and gravity. Each star does more than shine. It gives off heat. It pulls on everything around it with gravity. If a planet receives energy from multiple stars, its climate can become far more complicated than Earth's. When both suns are positioned in a way that sends more heat toward the planet, the hot season could become extreme. Oceans, if they exist, may evaporate more aggressively. Storms may become more violent. The atmosphere may fluctuate more rapidly. But when the planet moves into a region where it receives less energy, temperatures may drop sharply. A long, cold season may arrive. Ice may spread. Any ecosystem there would have to survive. Swings that Earth's biosphere might not be able to handle. And if the gravitational pull between the stars becomes too complex, the planet orbit may not remain stable over long timescales. A planet could be pulled out of place, pushed farther away, or, in an extreme case, thrown out of the system entirely, becoming a rogue planet, drifting in darkness. Here, the universe shows us a subtle truth. Beauty does not always mean safety. A sky with two suns would be breathtaking, but it could also be a sign of an environment far harder to live in. Human beings are often drawn to things that shine. More light, more choices, more opportunities, more things to chase. But more is not always better. A planet with an extra sun is not necessarily more peaceful. It may be hotter, more unstable, more difficult to live on. And human life can be similar. Sometimes we think we need more of everything, more goals, more recognition, more work, more approval, more sources of light from the outside world. But the more forces pull on us, the easier it becomes to lose our orbit. The more light shines on us, the harder it can be to find the darkness we need in order to rest. Life does not only need energy. Life needs rhythm. It needs pauses. It needs enough balance not to be torn apart by too many directions at once. That is why Earth becomes so worth contemplating. We have only one sun, but that one sun is enough to warm the oceans, enough for plants to grow, enough for day and night to take turns, enough for life to adjust over time. One is not necessarily too little. For Earth, one may be exactly enough. And in the universe, enough may be far rarer than we think. Still, science has not closed the question of life in multi-star systems. Some planets in binary star systems could, in theory, exist within a habitable zone if their orbits are stable enough, if the distance is safe enough, if the radiation is not too intense. Life may have a chance, but that life, if it exists, would likely be very different from us. It would not see the sky the way we do. It would not experience day and night the way we do. It would not measure time the way we do. To that life, two suns might be perfectly normal. A sky with only one sun, like Earth's, might be the strange one. This is what makes the universe humbling. What we call normal is only normal because we were born here. Rain made of water, a 365-day year, a single sun, a night dark enough to rest, a morning bright enough to begin. All of these are Earth's standards, not the universe's requirements. And when we understand that, we begin to place ourselves a little less at the center. We become less likely to think that everything must resemble our experience in order to be valid, less likely to call what is different wrong, simply because it does not match what we know. The universe is not strange because it is broken. It is strange because it is larger than our habits. A planet with multiple suns may amaze us, but for that planet, it may simply be the sky it has always known. There is also a quiet human reflection here. Each of us lives under a kind of sky. Some people live under a steady source of light, a clear purpose, a simple rhythm, an inner life that is not pulled in too many directions. Others live under too many suns, too many expectations, too many voices, too many things to satisfy. Not everyone with more light is more at peace. Not everyone with more choices is more free. Sometimes freedom begins when we recognize which source of light truly matters and which ones are only pulling us into disorder. A planet needs a stable orbit to survive over time. A human life needs an inner axis to live deeply, not to stand still forever, but to move without losing itself. Planets with multiple suns are a beautiful cosmic file, but they also come with a warning. They remind us that light needs balance, energy needs rest, beauty needs conditions that can sustain life. And when we look back at Earth, we see something simple but precious. Our sky is not too complicated. One sun rises, one sun sets, night comes, dark enough for humans to sleep, for living things to recover, and for us to see the stars. Without night, perhaps we would never have realized that there is a universe beyond us at all. Darkness, then, is not the enemy of light. It is the other half that helps life stay balanced. But not every planet has that balance. Some worlds have too many suns, and some worlds have no sun at all. If planets with multiple suns are stories of light made too complex, the next file takes us into the near total absence of light. No sunrise, no sunset, no new day, no parent star to call home. Only a lonely planet. Rogue planets, the sunless ghosts of the universe. If planets with multiple suns overwhelm us with too much light, the next file takes us to the complete opposite extreme. A world with no sun at all, no sunrise, no sunset, no golden light spilling over the horizon, no parent star hanging in the sky to mark the beginning of a new day. Only darkness, a darkness so deep, so cold, and so endless that the idea of daytime nearly loses all meaning. These worlds are called rogue planets. They are planet-sized objects that do not orbit any star. They do not belong to a stable star system. They have no familiar orbit around a sun. They have no home in the way we usually understand a planet. They drift alone through the space, between stars, silent as giant ghosts moving through the Milky Way. And the unsettling part is this: they may not be rare at all. In our familiar imagination, a planet always belongs to a star. Earth belongs to the Sun. So do Mars, Jupiter, and Saturn. They are all part of a system. There is a center. There is order. There is gravity holding everything in a long, stable dance that can last billions of years. But the universe is not made only of peaceful systems. In the early stages of a star system, things can be far more chaotic. Young planets form inside disks of gas and dust surrounding a newborn star. At first, they may not be stable. They pull on one another, push one another, disturb one another's orbits. A giant planet may move inward, disrupting the entire system. A smaller planet may be flung outward by the gravity of larger worlds. One strong gravitational encounter can change the fate of an entire planet. And then, in absolute silence, that planet is thrown out of its home system. No explosion, no dramatic flash like in a movie, no farewell. It simply moves farther and farther away from its parent star. At first, that star may still appear bright and large in the sky. Then it becomes smaller, fainter, colder in the planet's experience, until eventually, the sun that once stood at the center of everything becomes just one tiny point of light among countless others, and that planet becomes an orphaned world, an exile of the cosmos. Now imagine if that happened to Earth. Some gravitational catastrophe sends our planet out of the solar system. At first, perhaps humanity would still see the sun, but it would slowly shrink in the sky. The light would weaken, temperatures would fall, the seasons we know would disappear. No spring, no summer, no autumn, no winter, only one endless winter, stretching forward without mercy. The oceans would begin to freeze from the surface down. Forests would die without sunlight. Food chains would collapse. Cities would sink into darkness and cold. Without technology, far beyond anything we have today, human civilization would be pushed to the edge of survival very quickly. After enough time, Earth would no longer be the blue planet. It would become a dark, frozen sphere, drifting between the stars like a memory that had been lost. A world that once had oceans, forests, and human voices swallowed by the dark. That is the haunting nature of rogue planets. They do not need erupting volcanoes. They do not need asteroid impacts. They do not need a loud catastrophe. All they need is the loss of their parent star, and almost every familiar condition for life can collapse. But what makes this file even more mysterious is that a rogue planet may not be completely dead. That sounds like a contradiction. Without a sun, how could a planet support life? Without light, where would energy come from? Without day and night, how could any cycle exist? But science shows us that life, if it exists, does not necessarily have to look like life on Earth's surface, on our own planet, deep at the bottom of the oceans. There are ecosystems that do not directly depend on sunlight. They live near hydrothermal vents. There, heat from Earth's interior and chemical reactions provide energy. No sunlight, no green plants, no sky, and yet life exists. That opens a haunting possibility. If a rogue planet has a thick outer shell of ice and beneath it an underground ocean warmed by heat from the planet's core, could life survive there? Not life like forests, birds, or humans, but quiet forms of life beneath the darkness, organisms that have never known sunrise, never known the sky, never known that above the thick ice, their entire planet is drifting silently through the galaxy. That is what makes rogue planets both terrifying and fascinating. They are symbols of absolute loneliness, but they may also hide forms of life completely unlike anything we know. A world with no sun, but not necessarily no secrets. A dark place, but not necessarily an empty one. An abandoned planet that may still carry an unseen ocean deep within. And here is where the science becomes even more thrilling. How do humans find planets that are almost invisible? A normal planet can be detected when it passes in front of its parent star, causing the star's light to dip slightly, or through the gravitational tug it creates, making its star wobble just a little. But a rogue planet has no parent star. It does not shine like a star. It has no nearby light source to reflect in any obvious way. It is like a black stone drifting through a black ocean on a moonless night. So how can we detect it? One important method is called gravitational microlensing. When a rogue planet passes in front of a more distant background star, the planet's gravity can bend the light from that star. For a brief moment, the background star may appear to brighten in an unusual way, very slightly, very quickly, but enough for scientists to realize that an unseen object has passed in front of it. We do not see the planet directly. We see the trace its gravity leaves on light, like not seeing a person move through a dark room, but watching a candle flame tremble as they pass, a tiny sign, a fleeting motion, a clue in the dark. And from that clue, humans infer the existence of a lonely world. There is something beautiful about that kind of science. Science is not always about seeing something directly and then drawing a conclusion. Sometimes it is the art of reading traces, a dimming of light, a star brightening unexpectedly, a slight shift in an orbit, a repeated signal. From very small changes, human beings uncover enormous truths. At the same time, this teaches us humility, because what we know about rogue planets is still very limited. We cannot yet say with certainty how many of them exist in the Milky Way. We do not know what most of them are made of. We do not know how many are gas giants, how many are rocky worlds, how many have hidden oceans, and how many are simply frozen dead spheres. Many questions remain open, and those unanswered questions are exactly what make this file so compelling. Were some rogue planets once like Earth? Did they once have oceans, atmospheres, and sunlight before being thrown out of their systems? Could life still exist beneath the thick ice of an orphaned planet? If so, what would that life look like? Would it need to know the sun? Would it need to know it lives inside a galaxy? Or would it simply exist, quietly, for ages, deep beneath the surface of a world that has been covered in darkness for billions of years? These questions do more than spark curiosity. They touch something deeply human, because every one of us has, at some point, felt a little like a rogue planet, not physically, but emotionally. There are times when we feel lost, as if we have been knocked out of our familiar orbit, as if we have drifted away from the sources of light that once made us feel safe. There are moments when everything around us becomes silent, cold, and uncertain, and we do not know where we are drifting. But the image of a rogue planet has another side. Even without a sun outside, it may still hold warmth within. Even if the surface is dark, there may still be a quiet ocean below. Even as it drifts through darkness, it may not be completely empty. That is a subtle but powerful reflection. Human beings can be the same. There are seasons when the outer light disappears. No praise, no support, no sense of certainty. But if there is still a small source of warmth inside, patience, awareness, the ability to keep observing, a quiet belief that one can keep going, then darkness does not necessarily mean the end. It may be a long pause, a place where deeper things are preserved, a time when we learn not to depend entirely on light from the outside. But this should not become easy comfort. A rogue planet is still an extreme environment. Darkness is still dangerous. Losing a parent star would still be a catastrophe for most surface life. The universe is not gentle simply because humans want it to be gentle. But within that cold truth, there is another kind of peace. Peace does not mean denying the dark. Peace means looking directly into the dark without rushing to imagine monsters inside it. Science does this. It does not panic before the blackness of space. It measures, observes, waits, looks for traces, and accepts that some things take a very long time to understand. Perhaps human beings need to learn something similar. Not every mystery must be solved immediately. Not every dark season requires an instant answer. Sometimes, the right thing is to keep a mind clear enough to keep observing, even when there is no sunrise yet. A rogue planet, then, is not only a cosmic file, it is a quiet image of existence itself, a world separated from its source of light, yet still carrying an untold story, a ghost moving through the galaxy, but not necessarily without meaning, a mystery we cannot yet see directly, but continue to follow through the faint traces it leaves behind. And when we look back at Earth after this file, our own luck becomes even clearer. We have a stable sun. We have day and night, a sky bright enough to live under and dark enough to rest beneath. We have seasons, water, warmth, and familiar signs that tell us we are home. Sometimes the miracle is not a planet with a breathtaking view. Sometimes the miracle is simply a planet that has not been abandoned, a planet still held in an orbit just right, a planet where morning still arrives, no matter how long yesterday felt. But the universe is not only filled with cold darkness. After these sunless worlds, we move to the opposite extreme, a world scorched by light so intensely that metal can vaporize, a place where rain does not fall to nourish life. It falls like red-hot drops from a planetary furnace, the planet where it rains molten iron. After the cold darkness of rogue planets, we move to the complete opposite extreme, a world that does not lack light, does not lack heat, was not abandoned in the emptiness between the stars. Instead, it is heated so intensely that every familiar idea we have about weather begins to fall apart. There, the sky may still have clouds, the atmosphere may still move, winds may still blow from one region to another, and rain may still fall. But that rain is not water, not clean drops falling on a rooftop, not the kind of rain that makes trees greener, not the kind that makes a quiet afternoon feel calm. On this planet, the rain is molten iron. Imagine looking down at a giant gas planet orbiting extremely close to its parent star, so close that the planet no longer seems warmed by its star. It seems placed at the mouth of a cosmic blast furnace. One half of the planet always faces the star. That side is scorched continuously by light. No night, no darkness for rest, no soft sunset to cool the sky. Only an eternal day, red, violent, and relentless. On that day side, the temperature becomes so extreme that iron can vaporize in the atmosphere. Iron, the material we associate with bridges, blades, machines, factories, and solid structures here on Earth, no longer remains solid there. It is heated, melted, then turned into metallic vapor, suspended in the atmosphere like part of the weather itself. That is the kind of idea that pulls human imagination far beyond anything familiar. To us, an atmosphere means air, water vapor, clouds, and wind. But on an extreme world, the atmosphere can carry vaporized metal, and weather is no longer a story about water. It becomes a story about matter pushed to its limits. From the day side, enormous winds carry iron vapor toward the darker, cooler side of the planet. These are not gentle breezes moving through leaves, not monsoon winds, not ocean storms, like the ones we know on Earth. They are violent, atmospheric currents trying to balance heat between two halves of the same world, one side blazing, the other cooler, yet still brutally hostile. When the iron vapor reaches the cooler region, it begins to condense from metallic vapor into glowing liquid droplets, and then it falls, drop by drop, streak by streak, storm by storm, a rainstorm of molten iron. If there were a device strong enough to record that scene, the image might leave us speechless. A dark red sky, metallic clouds twisting in the atmosphere, winds carrying heated material across the planet, and from high above, bright drops of iron falling through the air like fragments of fire. No soft sound of rain on the ground, no damp earth, no scent of grass after a storm, only a rain from hell, a rain that proves this planet was not made for life as we know it. One of the most famous examples linked to this phenomenon is WASP-76b, a giant exoplanet orbiting very close to its parent star. In the script you provided, WASP-76b is described as a world where extreme heat may cause iron to vaporize on the day side, then condense and fall as iron rain in cooler regions. What is remarkable is that humans have never been there. No spacecraft has flown through that iron rain. No camera has directly recorded drops of molten metal falling from the sky. So how can scientists know? The answer is hidden in light. When a planet passes in front of its parent star, some of the star's light travels through the planet's atmosphere before reaching our telescopes. As that happens, the elements in the atmosphere absorb certain wavelengths of light. Each element leaves something like a fingerprint. Iron leaves the signature of iron. Sodium leaves the signature of sodium. Hydrogen, water vapor, and other molecules leave their own patterns as well. By analyzing how the light changes, scientists can infer what the atmosphere of a distant planet contains. This is one of the most beautiful things about space science. We do not need to touch a world to begin understanding it. We do not need to hear the rain to know that rain may exist. We do not need to stand beneath that alien sky to read part of its story. All we need is light passing through an atmosphere, carrying tiny traces with it, and the patience to decode them. From a very subtle change in the spectrum, we can reconstruct the image of a planet where iron may rise into the sky and fall back down as rain. A massive mystery can begin with a clue so small it is almost unbelievable. This also reminds us that the universe does not always speak loudly. It does not always reveal itself through explosions, blinding flashes, or scenes easy to see. Sometimes it leaves only the faintest absence in the light, a slightly altered curve, a dim absorption line, a fragile clue, and from that, an entire world appears. But WASP-76b also raises a larger question. How strange can weather on exoplanets really become? If there is a planet where it rains iron, could there be worlds where it rains glass? Are there planets with metallic clouds? Are there worlds where winds do not move through forests or across oceans, but through atmospheric layers filled with vaporized material? Are there planets where what falls from the sky does not nourish life, but only reveals that matter itself has been pushed into an extreme state? We do not yet know the full answer, and that is what makes this file so captivating. It is not only about one bizarre phenomenon. It opens a door. Weather does not have only one form. Rain does not have to be water. Clouds do not have to be made of water vapor. Wind does not have to be a gentle flow of breathable air. Everything depends on the conditions of each world. On Earth, rain can be connected to life. But on another planet, rain may be the sign of a furnace operating on a planetary scale. The same word, rain, can carry a completely different meaning when the conditions change. This is where a quiet human reflection can enter the story. In life, we often use the same words for very different experiences. One person may call something pressure, and that pressure helps them grow. Another person may face pressure, and it slowly wears them down. Someone may call a relationship light, but that light can either nourish or burn, depending on how it exists in their life. One rainstorm can make trees greener. Another rainstorm can be molten iron. The same name does not guarantee the same nature. What matters is the condition that creates it. What temperature, what distance, what pressure, what environment. The universe teaches us to look more deeply at context instead of stopping at the surface of a name. After this file, even an ordinary rainstorm on Earth begins to feel different. Here, rain is water. Water falls from clouds, flows into rivers, soaks into soil, helps plants grow, moves through the bodies of living things, then evaporates and returns to the sky. A soft cycle, a breath of the planet. We have lived inside that cycle for so long that we easily forget how precious it is. Only when we learn that there are places where rain may fall as molten metal do we realize that water rain is not ordinary at all. An atmosphere that can form water clouds is not ordinary. A temperature gentle enough that water does not all boil away or freeze forever is not ordinary. Earth is not perfect, but it holds a balance that many worlds do not. Warm enough for water to cycle, cool enough for water not to vanish, thick enough in atmosphere for rain to form, stable enough for life to grow with that rain. Here, rain is not the sound of hell striking the ground. Rain is part of life. Perhaps understanding the planet where it rains iron is not meant to make us fear the universe. Maybe it is meant to make us pause. One day, when we hear rain outside the window, not in sadness, but in recognition that we live on a world gentle enough for the sky to fall as water, and that may be far rarer than we think. But if WASP-76b can vaporize metal and turn it into rain, it is still not the final extreme of heat. Out there are planets heated so intensely that their temperatures exceed those of some small stars. They are not stars, and yet they are hotter than stars. Their atmospheres are torn apart. Molecules break down. Material leaks into space every second. A giant planet continues to orbit its parent star, but it may be slowly losing itself in silence. The planet hotter than a star. If the planet where it rains molten iron made the universe feel like a cosmic foundry, the next file pushes that idea even further. Because there are planets that are not merely hot enough to vaporize metal, not merely hot enough to turn the atmosphere into a violent storm of matter. Some planets are so hot that their temperatures exceed those of certain small stars. It sounds like a contradiction. In our normal way of thinking, a star is the symbol of fire, light, and heat. A planet, on the other hand, is supposed to be cooler, darker, and dependent on its star for energy. The star shines, the planet reflects. The star is the source of heat. The planet is the object being warmed. But out there, the universe does not always obey human intuition. Some planets exist in conditions so extreme that they become infernal worlds, hotter than the coolest red dwarf stars. One of the best-known examples is KELT 9b, a giant gas planet orbiting extremely close to a blazing hot star. In the script you provided, KELT 9b is described as one of the hottest known planets, with a dayside temperature that can exceed that of some small stars. Imagine a planet larger than Jupiter, but instead of orbiting far from its star, like the gas giants in our solar system, it orbits dangerously close. So close that the star's light no longer feels like a source of life. it becomes a relentless bombardment of heat, radiation, and stellar wind. Every second, the planet is being scorched, pulled, eroded, attacked by the overwhelming energy of the star beside it. If WASP 76b is hot enough for iron to vaporize and fall as rain, Kelt 9b is even more extreme because its atmosphere may be pushed to the point where molecules can no longer hold themselves together. Chemical bonds break apart, hydrogen can be torn away, elements in the atmosphere become energized by intense radiation. The outer layers of the planet swell, escape its gravity, and spill into space like a stream of heat leaking from a dying world. This is not a planet living peacefully. This is a planet slowly losing itself, layer by layer, piece by piece, orbit by orbit. There is no giant explosion, no single apocalyptic flash. Instead, there is a slow death stretched across millions, perhaps hundreds of millions, of years, a patient kind of destruction. Here on Earth, we often fear sudden disasters, an impact, an earthquake, a storm, a single moment that changes everything. But in the universe, some fates do not end with a bang. They end through erosion, a little lost each day, another layer stripped away, each orbit, another trip around the star, bringing the planet closer to exhaustion. A planet like KELT 9b is still there. Telescopes can still detect it. It still has a name. It still follows an orbit. But if we look deeper, it is like a candle placed in a violent wind, not extinguished yet, but burning through what remains of itself. What makes KELT 9b especially extreme is its parent star. That star is extraordinarily hot, far hotter than our sun. When a giant gas planet orbits too close to a star like that, it receives an enormous amount of radiation. Its dayside temperature rises beyond what we usually associate with a planet. And here, an important question appears. If a planet can be hotter than a star, where is the boundary between a planet and a star? The answer is not simply surface temperature. A star is a star because it has enough mass to sustain nuclear fusion in its core, fusing hydrogen into helium and producing its own energy. A planet, no matter how hot it becomes from being roasted by its parent star, does not shine in that way. It is not a self-sustaining nuclear furnace. It is an object being heated from the outside, like a stone placed too close to a fire. The stone may glow red. It may become too hot to touch, but it is not the flame itself. KELT 9b is the same. It is hotter than some small stars, not because it is more powerful than a star, but because it has been placed too close to an unbelievably intense source of energy. This reveals something important about the universe. The nature of a thing is not defined only by how it appears. Something may glow, burn, and seem violent, and still not be a star. Something else may be small and faint, yet contain enormous mass and gravitational power. Human life can be like this too. We are easily fooled by outward appearance. Someone may look radiant, but that does not mean they are at peace. A life may look successful from the outside, but that does not mean they are at peace. A life may look successful from the outside, but that does not mean it is not being worn down from within. A person may always seem to be moving fast, But that does not mean they are moving in the right direction. A planet hotter than a star reminds us that extreme appearance does not always reveal true nature. We have to ask where the energy is coming from. Is it being generated from within, or is it simply being burned into the object by pressure from the outside? That question is worth sitting with, because sometimes human beings also become like a planet scorched by a star that is too close. We are pulled toward enormous pressures, expectations, reputation, money, comparison, the fear of being left behind. We think we are shining, but perhaps we are being burned. We think we are strong, but perhaps we are losing our inner atmosphere, our calm, our sleep, our patience, our ability to enjoy simple things. A planet like KELT 9b cannot choose to move farther away from its star, but human beings, in many cases, can learn to create distance from the sources of heat that are burning them. Not every light is meant to be approached. Not every dazzling opportunity is suitable for a long life. Some things grow hotter the closer we get. Some things become more exhausting the more we achieve. Some things make us lose ourselves the tighter we hold on. The universe does not say this in words. It simply shows us a giant planet heated so intensely that its atmosphere slowly escapes into space. And from that image, we understand something about balance, about distance, about the fact that being close to a source of light is not always good. Scientifically, ultra-hot planets like KELT 9b are incredibly valuable natural laboratories. On Earth, we cannot easily recreate an entire planetary environment with extreme temperatures, intense radiation, a breaking atmosphere, and material escaping into space on a massive scale. But out in the universe, those conditions are real. Scientists study the light from the star and planet to understand what its atmosphere contains, how temperature is distributed, how material escapes, and how long a giant gas planet can survive under such brutal radiation. That data does not only help us understand one distant world, it helps us understand how planets evolve. A planet at birth may be very different from the planet it becomes after billions of years under the influence of its star. Atmospheres can be lost, orbits can shift, surfaces can transform. A world that once seemed stable can slowly become a remnant. And by studying planets being eroded, we also learn what conditions allow a planet to keep its atmosphere, hold on to water, and remain capable of supporting life. In other words, studying cosmic hellscapes also helps us understand why Earth has not become one. Earth is not too close to the Sun. Its atmospheric molecules are not being torn apart on a massive scale by extreme heat. The solar wind has not stripped away our protective layer. Our temperatures are not high enough for rock and metal to vaporize. We live in a zone of just enough. Not too hot, not too cold, not too close, not too far. That balance may sound simple, but in the context of the universe, it is almost miraculous. When we look at KELT 9b, we see a giant planet with nowhere to hide. It is large, but still fragile. It has mass, but it is still being eroded by radiation. It orbits a dazzling star, but that same brilliance is the source of its destruction. This breaks a common illusion. That being big means being safe. In the universe, a planet larger than Jupiter can still be vulnerable if it is in the wrong place. In human life, a person with many achievements, possessions, or influence can still be worn down if they live too close to toxic pressure. Size does not guarantee peace. Strength does not guarantee endurance. What matters is the orbit, the distance, the balance between receiving energy and not being destroyed by it. And perhaps that is the deepest reflection left by these ultra-hot planets. Not everything bright is worth chasing. Some lights are beautiful only from a distance. Some sources of heat are useful only when we do not stand too close. Some ambitions nourish us only when we do not turn ourselves into fuel for them. The extreme universe does not need to frighten us. If told honestly, the truth is already powerful enough to leave us silent. A planet hotter than a star keeps orbiting its parent star. It does not complain. It does not resist. It does not ask questions. The planet larger than its star, one of the universe's most impossible-sounding ideas. In the way we usually imagine a planetary system, the order feels obvious. At the center, there is a star, huge, brilliant, massive, powerful enough to control everything around it through gravity. And around it, smaller, darker, colder planets move quietly, orbiting like companions to that central light. Our own solar system makes that picture feel even more certain. The Sun is far larger than Earth, far larger than Mars, Venus, or Mercury. Even Jupiter, the largest planet in our solar system, is still tiny compared with the Sun. So when we hear the question, could a planet ever be larger than the star it orbits? Most people's first reaction is this: that sounds impossible. How could a planet be larger than its own star? If it is larger, why isn't it the center? Why does the smaller star still hold that planet in orbit? It sounds like a contradiction, but the universe has a way of making our most obvious assumptions begin to shake. And to understand this file, we need to separate two ideas that are often confused: size and mass. An object can be physically large without being the heaviest object in the system, and an object can be small while still containing an enormous amount of mass. On Earth, the simplest example is a balloon and a steel marble. A balloon can be much larger than the marble, but the marble is heavier. In the universe, that difference becomes far more extreme. There are dead stars, or stellar remnants, that are very small in size, but incredibly massive. One of the most important examples is a white dwarf. A white dwarf is the leftover core of a star, similar to our Sun after it reaches the end of its life. As the star runs out of fuel, it expands into a red giant, sheds its outer layers, and leaves behind a small, hot, dense core. That core is the white dwarf. A white dwarf may be only about the size of Earth, but it can still contain a tremendous amount of mass. It is small but dense. It fades over time, but its gravity remains powerful. And if a giant gas planet orbits a white dwarf, that planet may be physically larger than the star it orbits. In the script you provided, the section, "The Planet Larger Than Its Star," explores this exact idea. A tiny star or stellar remnant, such as a white dwarf or neutron star,
can be smaller in volume than a planet, while still having enough mass to hold that planet
in orbit. Now imagine that scene. There is no golden sun dominating the center of the system, no gentle light like a morning on Earth. At the center is only a small white point of light, cold, dense, and eerie, the remnant of a star that has already died. Around it, a giant gas planet continues to orbit. That planet may be larger in diameter than the star itself. From a distance, everything looks reversed. The object at the center appears small. The object orbiting around it appears huge. But gravity is not fooled by what looks larger. Gravity does not ask, which object takes up more space? It asks, which object contains more mass? And a white dwarf, despite being small in size, can still be far more massive than the planet orbiting it. It is like a small white ember left behind after a great fire. It no longer blazes the way it once did. It no longer shines like a young star, but inside it, an extraordinary weight remains compressed. The giant gas planet may look enormous, but it is still the follower, still held in orbit around the dead star. This is the first reason this file is so fascinating. Appearance does not reveal the whole truth. The largest thing is not always the center. The smallest thing is not always weak. The faintest thing is not always powerless. And the object that looks most impressive to our eyes may not be the one truly controlling the system. Human life works this way too. We are easily pulled toward things that are large, bright, loud, and visible. A person who looks successful, a position that appears powerful, an image that seems glamorous, a voice that dominates the room. But sometimes, the things that carry real weight are much quieter. A principle that someone lives by, a patience that does not need applause, a promise kept over time, an inner steadiness that is not easily pulled off course. Some things do not need to take up much space to hold a life in orbit. Just like that small white dwarf, it is not large, but it is heavy. It is not dazzling, like a young star, but it still has gravity. And yet, this file is not only strange because of size. It opens a larger mystery. How did that planet survive? A white dwarf does not begin life in that small, dense form. Before becoming a white dwarf, its star was once a normal star. It had light. It had a stable period. It may have had an entire planetary system orbiting around it. Then, as it aged, it expanded into a red giant. During that phase, the star grew enormously. Planets close to it could have been scorched, swallowed, or thrown into chaotic orbits. After that, the star shed its outer layers and collapsed down into a white dwarf. So if we now see a giant gas planet orbiting relatively close to a white dwarf, the mystery becomes almost like a cosmic crime scene. Was that planet always there, somehow surviving the star's red giant phase? Or was it once farther away, only to be pushed or pulled inward after the star had already died? In systems like this, scientists have to ask, is this planet a survivor? Or is it an object that was thrown into a new orbit after catastrophe? A dead star, a planet still moving, an orbit that is difficult to explain, a past hidden beneath billions of years of change. This is not just a planetary system. It is an investigation, and scientists have to read the remaining traces to understand what happened. One possibility is that the planet once orbited much farther away in a safer region. Then, after the star became a white dwarf, the system lost its old balance. Other planets, if they existed, may have interacted gravitationally. A giant planet could have been pushed inward, eventually settling into a new orbit close to the white dwarf. It was not destroyed. It was not swallowed. It survived, but not because everything had been peaceful. It survived because, after chaos, it found a new orbit. That is what gives this image so much depth. A planet larger than its star is not only a shocking size comparison, it is a symbol of continuation after an ending. The parent star once shone brightly, then it aged, expanded, lost its outer layers, shrank into a remnant. Part of the planetary system may have been destroyed, but not everything vanished. Something remained. Something kept moving. A planet continued to orbit the dead core of the star that once lit its system. The universe here is not telling a happy story, but it is not telling a story of total despair either. It is telling a story of transformation. An old order ends. A new order forms. Colder, quieter, stranger, but still moving. In human life, we often fear endings. We fear the end of a chapter, the end of a job, the change of a relationship, the loss of an old version of ourselves. We often imagine that when a sun in our life goes out, everything else must end with it. But the universe shows us that some stories continue, even after a star dies. Not in the same form, not with the same brightness, but with an orbit, with motion, with the possibility of a new order. That does not mean loss is easy. It does not mean upheaval should be romanticized. A star expanding into a red giant can destroy many planets. A major change in human life can leave real wounds. But if we look deeply enough, we see that after upheaval, there is not always only emptiness. Something essential may remain. A different rhythm may remain. A new version may remain. Less dazzling, but perhaps more real. This reflection should stay gentle in the video. Not as a lecture, just as an image the audience can feel. A giant planet orbiting a small dead star, a cosmic graveyard, but not entirely silent. A stellar remnant still holding gravity, a great ending, but not an absolute full stop. Scientifically, planets around white dwarfs are also important because they may reveal the far future of our own solar system. Right now, the sun is still stable. It rises every day. It warms Earth. It keeps our climate within a range that allows life to exist. But the sun will not remain in its present form forever. In the very distant future, it will also age. It will expand. It will shed its outer layers, and eventually, it will leave behind a white dwarf. By then, the solar system will no longer look the way it does now. The inner planets may face a brutal fate. The outer planets may survive, but their orbits and environments may change. So when we study planets around white dwarfs, we are not only studying some strange exoplanet far away, we are also looking at one possible chapter in the distant future of our own star system. Not to frighten ourselves, this future lies on timescales far beyond a human lifetime. But to understand that every star has a history, every planetary system has an age, and even the things we think of as most stable in the sky are part of a slow, vast process of change. Knowing that does not make the present darker. In fact, it can make the present feel more precious, because today, the sun is not a white dwarf. Earth is still in an orbit that is just right. Water still flows. Rain still falls as water. The sky still has one sun, and we still have time to ask questions, to learn, and to live more carefully on the planet that supports us. One day, far beyond us, everything will be different. But because of that, this present moment is worth seeing with clear eyes, not with panic about the distant future, not with anxious attachment to the present, but with the recognition that everything is moving, and the stability we have right now is something to value. The file of a planet larger than its star teaches one more thing. The universe does not always obey the simple images in our heads. A star is not always larger than a planet in physical size. A larger planet is not necessarily the stronger object. A system that looks impossible may make perfect sense once we understand mass, density, stellar evolution, and orbital history. That is the beauty of science. It does not only give us information, it corrects our intuition. It reminds us that reality does not have to match what we first imagined. And every time science forces us to revise an old belief, we become a little less arrogant, a little less quick to judge, a little less likely to think we understand everything just because we have seen the surface. A planet larger than its star is a powerful story because it has 3 layers. The first layer is the shock, a planet larger than a star. The second layer is the science. Size is not mass. A white dwarf is small but extremely dense. The third layer is the depth. Appearance does not reveal essence, and after a great ending, motion can still remain. If told well, the audience does not only think, that is strange. They feel something quieter. Some small things are heavy. Some large things are still held in orbit. Some endings do not erase every story, and some remnants still carry gravity in the dark. From scorched planets to planets orbiting dead stars, we have traveled through many extremes of the universe. But the next file has a different kind of beauty. Not a planet hot enough to fall apart. Not a world alone in darkness. Not a planet larger than its star, but a world that may be almost impossibly beautiful. A planet surrounded by a gigantic ring system, not like Saturn's familiar rings, but a structure so vast that from nearby it could stretch across the sky like a bridge of light made of dust, rock, and ice. And yet, that beauty comes with an unresolved question. Is it truly a planet with enormous rings? Or is it a signal we have not fully understood? The mega-ring planet, the cosmic ring. Scientists are still debating after planets so hot their atmospheres are torn apart, after worlds drifting alone in darkness, and after planets orbiting the remnants of dead stars. The next file takes us into a different kind of mystery. Not a mystery because it looks like hell, but a mystery because it may be almost impossibly beautiful. A planet surrounded by a gigantic ring system Not the thin, elegant rings we usually associate with Saturn, but a structure so vast that if you stood nearby and looked up, the sky itself might be filled with enormous curved bands of light, rings made of dust, rock, ice, and countless fragments orbiting around their parent world. Some regions would glow under starlight. Some would appear darker, where material is thicker. Some gaps might look like clean cuts through the system, places where a young moon may be quietly clearing a path through that massive disk of debris. If Saturn is the solar system's delicate jewel, then a planet with a truly massive ring system would be closer to a cosmic architecture, a bridge of light suspended in darkness, a ring so large that every familiar human scale suddenly feels small. One of the cases often mentioned in connection with this idea is J1407b. It is an object that drew attention because the light data suggested the possible presence of a massive ring system far larger than Saturn's. In the script you provided, J1407b is presented as a fascinating but still debated case, because after the original dimming event, a similar signal has not been clearly observed, again, as expected. And that word, possible, is exactly what makes the story so compelling. This is not a file that has been completely closed. It is not the kind of mystery where science already holds the final answer. It is a strange clue, a breathtaking possibility, a beautiful hypothesis, powerful enough to ignite the imagination, but still requiring caution. To understand why, we need to begin with how humans detect distant objects like this. When a planet passes in front of its star, the star's light dips slightly. If it is a normal planet, the dip in brightness is usually relatively simple. But if that planet has a wide ring system, the story changes. It is not only the body of the planet blocking the light. The rings also pass in front of the star. Depending on the ring's thickness, tilt, structure, and gaps, the star's light may dim in a far more complicated way. Sometimes the light drops sharply. Sometimes it drops more gently. Sometimes the pattern rises and falls, as if a multi-layered structure is sweeping across the face of the star. That is what made the data from J1407 so unusual. A deep and complex dimming event led scientists to ask, could an object with a gigantic ring system have passed in front of the star? If that explanation is correct, the ring system could be far larger than Saturn's, not just a narrow band wrapped close around a planet, but an enormous disk of material, possibly containing gaps where natural satellites may be forming. Now imagine that scene, a giant planet suspended in space. Around it, not a few delicate rings, but an immense field of material stretching outward in layers, bands, and open spaces. Dust and ice reflect starlight in cold, silver arcs. Rock and debris move silently in orbit. Somewhere within the rings, smaller objects collide, merge, and slowly grow over time. A moon may be forming inside that very ring system. If you stood on a nearby satellite, the sky would look nothing like Earth's. Not just stars, not just darkness, but a massive structure crossing space above you like a silver river curving around the parent planet. By day, the rings might reflect starlight. By night, they might appear like a vast, glowing road across the sky. At times, the shadow of the rings might sweep across the surface. At other times, the planet itself might block part of the light, creating long and strange eclipses. Beautiful, but not still. A ring system is not a solid, peaceful, unchanging object. It is a dynamic system. Countless small fragments are moving, colliding, being disturbed by the gravity of the planet and its moons. Some parts may gradually disappear. Some may gather into moons. Some gaps may form because an object is clearing its path. In other words, a gigantic ring system is not just decoration. It may be a construction zone for moons, a place where matter has not yet settled, a transitional stage in the long history of a planetary system. Today, it is a ring. Far in the future, parts of it may become moons, and this gives its beauty a deeper meaning. Some things are beautiful, not because they last forever, but because they exist at one particular moment in a process of change. A cloud is beautiful because it will pass. A sunset is beautiful because it does not stay. A season of flowers is beautiful because it blooms only for a while. A gigantic ring system may be the same. On the timescale of the universe, it may only be a temporary chapter, but that temporary nature does not make it less extraordinary. It makes it feel alive. Still, the story of J1407b must be told carefully. If we simply say, "This is a planet with giant rings," the video may sound more exciting for a few seconds, but it loses scientific honesty. This file is still open. It may be a ringed planet. It may be a brown dwarf with a disk of material around it. It may be some other object that passed by only once. It may be that the data reflects a structure more complicated than the original hypothesis. The important point is that a similar signal has not been clearly confirmed, again, as expected. So science has to remain cautious, and that caution does not make the mystery less interesting. It makes it more real. The audience is not only drawn in by the image of a giant cosmic ring, they stay because of the question. If it is not a ringed planet, then what is it? That is the power of an unfinished file. It does not hand us an easy answer. It lets us stand among several possibilities. And in that space, between possibilities, curiosity becomes stronger. Human beings often dislike uncertainty. We want to know immediately. We want quick conclusions. We want every file closed with a clear label: true or false, real or not real, yes or no. But the universe does not move at the speed of human impatience. Some signals require years of observation. Some hypotheses require repeated data. Some answers need time before they can emerge clearly. And sometimes, the most honest sentence is not, "We know," but, "We have seen something strange, and we need to keep watching." That is not failure. That is the maturity of understanding. It means knowing when to stop before claiming too much. Knowing how to hold a question open without rushing to fill it with imagination. Knowing how to let the unknown remain long enough for the data to speak. This is the reflective layer that fits this video. Well, it does not need religious language. It does not need to feel like a lecture. The audience only needs to feel this. Not knowing is not shameful. Sometimes, knowing that we do not yet know is the beginning of clarity. The same is true in human life. There are things we want to understand immediately. A turning point, a relationship, a failure, a confusing season inside ourselves. We want to name it quickly so we can feel less anxious. But some things become more confusing when we force an answer too soon, like a light signal without enough data. Some experiences need more time to observe, more silence, less urgency to label them, not to avoid the truth, but to see the truth more clearly when the conditions are right. A gigantic ring system, if it truly exists, would be a wonder. But even if that hypothesis changes, the search still matters, because the value is not only in the final answer, it is also in the way human beings learn to observe, to ask questions, to revise hypotheses when new data appears, to remain humble before a universe larger than imagination. And this connects beautifully back to Earth. When we look at Saturn, we see a ringed planet of extraordinary beauty inside our own solar system. When we imagine massive ring systems beyond our solar system, we realize Saturn may only be a small hint of what the universe can create. If something so beautiful exists close to us, then how many other structures may be hidden among billions of star systems? How many ringed planets have we not yet found? How many disks of material are forming moons? How many unusual dips in starlight are hiding cosmic architectures we do not yet have enough data to name? We do not know. And this time, we do not know does not end the story. It opens a kind of peace, because not every unknown needs to become a fear. Some unknowns are invitations to look more carefully, to become more humble, to accept that truth does not always arrive at the speed we want. The universe is not in a hurry. Planets keep orbiting. Light keeps crossing space. Data waits to be read. And after opening all of these files, perhaps what leaves us most silent is not only how strange each planet is, not only a world where a year is so short that just a few hours can complete an entire cycle, not only planets with multiple suns, where the sky shines in ways Earth has never known, not only rogue planets drifting alone through the darkness of the Milky Way, not only a place where molten iron falls as rain, not only a planet hotter than some small stars, not only worlds larger than the stars they orbit, and not only a giant cosmic ring that science is still debating. What makes us think more deeply is one simple truth. The universe was not made to resemble Earth. Earth is only one possibility, one case, one fragile balance among countless extremes. Because we were born here, it is easy to believe that everything around us is obvious. Rain is water. The sky has one sun. A day has light and darkness. A year is long enough for trees to grow, memories to form, people to change, and life to continue across generations. But when we look outward, we begin to realize that the things we call normal may not be normal at all. On another planet, rain may be molten metal. On another world, sunrise may never come. Farther away, The sky may hold 2 suns, 3 suns, or multiple sources of light arranged in complex stellar systems. There are planets being scorched so intensely that their atmospheres slowly escape into space. There are planets still orbiting the corpse of a dead star. There are planets so beautiful they almost seem unreal. Yet even their beauty remains an unanswered question. The vast universe does not promise that every world will be gentle. It does not promise that every mystery will have an immediate answer. It simply exists, silent, immense, and it leaves humanity with tiny clues. A star dims for a moment. A light curve behaves strangely. An orbit does not make sense. A faint signature appears in a spectrum. From those tiny clues, we reconstruct the portraits of worlds, hundreds or thousands of light years away. And perhaps that is the greatest wonder. Not only that the planets out there are so strange, but that on a small planet like Earth, there is a species capable of looking up and asking questions. We are not large compared with the universe. We are not powerful. We do not live long. A human lifetime is almost nothing compared with the age of a star. A civilization is young compared with the history of the galaxy. And yet, we have curiosity. We have the ability to observe. We have the ability to admit that we do not know. And that is what opens the door to understanding. In the search for the universe, one thing matters deeply. Not every mystery needs to become a fear. Some planets sound terrifying. Some worlds could never support life as we know it. Some environments are so extreme that simply imagining them is enough to make us uneasy. But the purpose of looking at them is not to panic. It is to understand the diversity of the universe more clearly, and to understand the value of the place where we stand. When we learn that there are planets where it rains iron, rain on Earth begins to feel different. When we learn that there are planets with no sun, an ordinary morning becomes precious. When we learn that some worlds are being burned away by their own stars, Earth's distance from the sun becomes something worth appreciating. When we learn that some planets can be thrown out of their star systems, a stable orbit becomes more than a scientific fact. It becomes one of the conditions that allowed life to begin. Sometimes, learning about the farthest places brings us closer to the present. An ordinary breeze, a night sky with stars, a soft morning light, a rainstorm made of water, a breath taken without thinking. In daily life, we often overlook these things, but placed beside the extreme worlds beyond our solar system, they become quiet gifts. No one needs to explain it too loudly. No one needs to turn it into a lecture. When we look widely enough, the heart softens on its own. And perhaps this is one of the gentlest lessons the universe offers. Not every answer needs to arrive immediately. Not every unknown is a threat. Some mysteries exist so we can learn patience in observation. Some darkness exists so we can understand the value of light. Some extreme worlds exist so we can recognize that Earth's ordinary conditions are not ordinary at all. Human beings often want certainty. We want to know everything quickly. We want to close the case as soon as possible. But the universe does not move at our impatient pace. A signal may require years to confirm. A planet may require dozens of observations before it can be understood. A beautiful hypothesis may need to wait for more data, and sometimes the most honest answer is still, we do not know yet. But not knowing is not failure. Not knowing is an open door. It is space for curiosity to remain alive. It is the reason human beings keep looking up. If everything were already clear, perhaps the universe would lose part of its power over us. It is the unanswered questions that keep us asking, keep us observing, and keep us moving beyond old limits. And in that process, we do not only learn more about planets, we learn more about ourselves. We learn that we are small, but not meaningless. We learn that we do not know everything, but we can still learn. We learn that peace does not come from controlling the entire universe. It comes from knowing where we stand, appreciating what we have, and continuing to observe without being carried away by fear. That is a quiet kind of peace. It does not need to be loud. It does not need grand words. It is simply the feeling of looking up at the night sky and knowing that countless unnamed worlds still exist out there, while right now, beneath our feet, there is a planet still giving us a chance to live. Earth is not perfect. It has storms, earthquakes, volcanoes, droughts, climate change, and many things humanity must learn to face with responsibility. But Earth is still the only world we know for certain that carries life, a place where rain can still make plants greener, where oceans still reflect the sky, where night is dark enough to see the stars, where morning still returns after a long night. And perhaps after traveling through the strangest planets, what remains is not fear of the universe, but a quiet gratitude for this planet, a small blue point in the vast dark, not too close to fire, not too far from light, not abandoned in the darkness, not losing its atmosphere every second. No iron rain, no multiple suns, turning day and night into chaos. Only a world fragile enough to be vulnerable, yet gentle enough for life to ask questions about the universe that gave rise to it. And that journey is far from over. New telescopes will continue to look deeper. New data will continue to appear. Even stranger planets may be discovered. Maybe one day we will find a world more unbelievable than everything we have just described. A planet with weather no one has imagined. A star system arranged in a way that forces science to rethink old assumptions. An underground ocean hidden in darkness. A light signal that makes scientists reopen an old file. And when that happens, we will have another mystery to explore, not with panic, but with awake curiosity, with humility, and with the feeling that each unknown thing out there is helping us understand this world more deeply. If you find cosmic files like this fascinating, subscribe to the channel so we can keep opening the strangest mysteries beyond our world, and leave a comment below. Out of all the planets mentioned, which one made you think the most? The planet with a year that lasts only a few hours? The planet with multiple suns? The rogue planet with no parent star? The planet where it rains molten iron The planet, hotter than a star? Or the possible mega ring planet that still remains? An open question in science? And if you had to choose one thing that makes Earth precious, what would it be? Rain made of water? A sky with only one sun? Or simply the feeling of waking up each morning and realizing this world is still calm enough for us to begin again. See you in the next file from Strange World Archives.